In this study, we ask, do first language neural processes for morphosyntax transfer to the second language? And we're going to use event-related potentials to expand the evidence of cross-linguistic influence. The native language constitutes an important foundation for second language learning. Transfer of L1 skills to the L2 is well attested behaviorally. For example, transfer of L1 literacy skills to the L2. However, whether this occurs at the processing level is still an open question. Interestingly, recent research has found similar variability in L1 and L2 processing of morphosyntax. In particular, both native speakers and L2 learners show ERP responses to morphosyntax that can be distributed along an N400 P600 continuum. However, the literature that examines whether L1 and L2 processing is similar within individuals is scarce and the results are mixed. Our research aim is to explore whether individuals' dominant processing strategy for L1 morphosyntax, that is either a P600 or an N400, is associated with their dominant processing strategy for L2 morphosyntax at early stages of learning. We gathered data from 42 participants who were native speakers of English and low intermediate level learners of Spanish, enrolled in 3rd and 4th semester classes. We recorded EEG while participants completed a task in which they judged the grammaticality of sentences. They did this both in English and Spanish in 2 counterbalanced sessions. We tested morphosyntactic processing through 2 conditions of interest: subject-verb and noun-phrase-number agreement. Words and sentences appear one at a time in the center of the screen. We followed our lab standardized procedures to record and process EEG data. Regarding ERP analysis, we looked at the data descriptively. First, at the group level, to examine overall group effects to grammatical and ungrammatical sentences, and also at the individual level, to see the spread of the responses across the N400 to P600 continuum. At the group level, we ran repeated measures de novas for the midline electrodes in 2 windows of interest: the 300 to 500 millisecond and 500 to 900 millisecond time window, which are representative of the neural patterns of interest, the N400 and the P600 respectively. At the individual level, we calculated each participant's N400 and P600 effect magnitudes in a central parietal region of interest in the time windows indicated above. To address the research aim, we calculated for each participant the response dominance index, which is a measure of individuals' relative response dominance in each language, whether dominant N400 or dominant P600 effects were elicited. And then we conducted correlations between English and Spanish RDIs to see whether participants' dominant response is associated across languages. Moving on to the results, first we're going to look at the behavioral data and the ERP data descriptively, in English DL1 on the left panel and Spanish DL2 on the right panel. Regarding performance in the grammaticality judgment task, in DL1 participants were highly accurate judging the grammaticality of sentences. In DL2 they were less accurate but still performed above chance. Now we're going to look at processing descriptively. First, we'll look at group effects, and then we'll look at processing at the individual level. Regarding group effects, in the L1 English, results revealed a P600 effect to both agreement conditions. However, no language-related ERP effects were evidenced for the L2 Spanish at the group level. Now, we're going to look at processing descriptively at the individual level. In the graphs, we have the average P600 effect magnitude on the x-axis, and on the y-axis we have the average N400 effect magnitude. Note that the two experimental conditions, subject, verb, and noun phrase agreement, are aggregated. Each dot is a data point from one participant. The dotted line represents equal N400 and P600 magnitudes. Participants above the line show primarily a negative effect, and those below the line show primarily a positive effect. As you can see in the graphs, results revealed variability in the distribution of brain response dominance for both L1 English and L2 Spanish morphosyntactic processing, with a continuum of responses ranging from negative dominant, larger N400s, to positive dominant, larger P600s. We can see that both English and Spanish, there's more people that fall under the line, that is, they show positive dominant effects. However, in English, VL1, more people showed positivity compared to Spanish. Now we transition from effect magnitudes to RDIs. Remember that RDI is a measure of participants' relative response dominance. That is, whether they are N400 dominant or P600 dominant. The scatter plots illustrate the connection between RDIs in English, DL1, and Spanish, DL2, for the noun phrase agreement condition on the left and the subject-verb agreement condition on the right. In both graphs, on the x-axis, we have the RDI values in Spanish, DL2, and on the y-axis, we have the RDI values in English, DL1. As you can see from the scatter plots and the results of the correlation analysis in the boxes under the graphs, we find evidence of a strong, significant connection between RDIs in English and Spanish for both the noun phrase and the subject-verb condition. In conclusion, we found variability in the processing of both L1 and L2 morphosyntax. It has been argued that these two ERP components, the N400 and P600, reveal that grammatical processing can proceed along two different routes. Speakers that elicit a dominant N400 effect are thought to engage in memory-based lexical associations, whereas those that show P600 dominant effects rely on combinatorial syntactic processing. Given the high accuracy scores in the grammaticality judgment task, we can conclude that both processing strategies are successful. Interestingly, we found significant variability among highly educated native speakers of English in the L1. As a consequence, and regarding the interpretation of L2 data, we wonder how strongly we can take the P600 as a proof of native-like or successful L2 processing. Regarding our research aim, results suggest that ERP response dominance may be a stable trait that is transferable across languages, thereby constituting a source of individual differences in morphosyntactic processing regardless of the language. Thus, we can conclude that cross-linguistic influence may also occur at the processing level. However, there are some limitations. First, at the group level, we were not able to find significant language-related ERP responses in the L2. That is, L2 processing may not be stable at the low intermediate proficiency level. Second, at the individual level, we did not find consistency in brain response dominance within languages. That is, RDIs were not significantly correlated within languages across experimental conditions. In the future, we want to replicate the results with a larger participant pool, and we also want to investigate this connection at different proficiency levels. These are my references, and do not hesitate to contact me with any questions or comments. Thank you.